Hi, now we have the fourth question, which is about the disk. It is almost like this one, with the radius 2.5 centimeters, which is equal to 0.025 meters. It is easy to convert that. It is like this one. It is rotating, I think. It will be because we have rotational motion. Let us look at its properties. Its mass is 600 grams, which is equal to 0.6 kilograms. Omega, the rotational velocity or angular velocity, is equal to 74 round per minute. We know how to change round per minute to radians per second. It will be just, we need to multiply 2 pi over 60. 2 pi over 60. It will be equal to 7.75 radians per second. The radius is 2.5 centimeters. We need it in meters. First of all, we need to find a moment of inertia. For a disk, the formula is half mr squared. Mr squared is the general formula for the moment of inertia, but the constant here is represent the shape of the body that rotates. Okay, now half m is given, r is also given in meters, then the moment of inertia will be equal 1.875 multiplied by 10 to minus 4 kilogram meter squared. I write it in this form, E, which is the same as multiplied by 10 to negative 4. So I'm sorry for that. Now, the angular momentum. Remember that the linear momentum P is equal to m multiplied by v. M is given. The velocity, we don't have linear velocity now. We are talking about angular momentum L, okay, which is equal to the angular effective mass, which is I, this one, we find it, and multiplied by omega, we find omega. Now, the angular momentum in this case is equal to this long number. We can use it as 1.45 multiplied by 10 minus 3. It is okay. This is the angular momentum. If we have a change now in C, if we have a change in angular momentum, is equal to 0.00067 kilogram meter squared per second. Okay. The initial angular momentum, this one, is changed. It's raised. Okay. We have a change in velocity. Maybe the velocity be higher a bit, then the angular momentum gets higher. So we know that every delta quantity is equal to the final quantity minus the initial quantity. We know the initial quantity. We need to find the final quantity. Now, the change in angular momentum is equal to this value, which is given, which is equal to L2 minus L1. L1, we find it now here, which is 0.001453. I approximate it to 1.5 just. And in this case, we need to move this term to the next side, add them together because this negative sign will be positive. The total angular momentum after this process will be L final, which is equal to 0.00217 kilogram meter squared per second. Okay, maybe you have a bit different value because the approximation. If this change in angular momentum, this change in velocity, okay, during 12 seconds, then we have change in angular velocity. So we have also acceleration, angular acceleration, alpha. We can find it. Okay, but now D part asks us about the torque. T torque is equal to change in momentum over the change in time, because we know that from before that the force is equal to delta P over delta T in linear motion. This is the relation between the change in momentum with the Newton's second law. Change in momentum is given, which is the given information in C, and the time period is given. So the torque is equal to 5.58 or 5.6 if you need to approximate it, multiplied by 10 to minus 5 Newton meter. Okay, this is the torque. I think it will ask us about part D will ask us about the angular acceleration, which is the torque divided over the moment of inertia. We know that Newton's second law, F is equal to ma. If we need A, it is equal to F over m. F in angular motion is the torque. M in angular motion is the moment of inertia. Moment of inertia, we found it before, which is 1.875 multiplied by 10 to minus 4. You can use it 1.9, for example, if you need to approximate it. And the torque is, we find it now. So the tangential, the angular acceleration will be equal to approximately 0.3 radians per second. So the tangential acceleration now. We have acceleration, we have change in velocity during a time. So we can also find the tangential acceleration, which is the radius multiplied by the angular acceleration. Angular acceleration, we find it, the radius is 2.5 centimeters. Then the tangential acceleration will be 0.0075 meters per squared second. This is a physical system, rotates, and you can find its properties. Do that by yourself many times. Thank you.